All right, still in Domain 2, Asset Security, we're going to talk about data standards in this section here. A standard is, by definition, kind of a structure that we follow or whatnot. Standards describe objects, features, or items collected, automated or affected by activities or functions of an organization. Now, that's a definition that is specific to data. But it makes sense if you read it, right? Standards describe the objects. They describe the data that we're collecting, the features of that data or the specifics of the information that was collected. How is the data automated, or how is the data affected by its use, its storage, etc., or what are the functions of the organization? We have to manage and organize according to a set of defined rules and or protocols. Always, this is always going to be our best bet, minimally complex standards. All right? In other words, let's adopt data standards that don't require a lot of overhead, don't require a lot of work, that meet our minimum standards, but also fit our largest target audience. If I'm defining standards that only apply to a specific subset of users, then I have to have multiple policies for different users, and it just gets more and more complex to manage. Now, we may not always be able to meet this objective, right? There is always going to be kind of that one-off scenario where we have to have a special use case. But consider different levels of standards. How is the data managed internationally or nationally or regionally or locally? All right. But what are the benefits of having these standards? We can have more efficient data management, especially if we're meeting this point right here. We can have increased data sharing, higher quality data, improved data consistency, better understanding of the data's use, usefulness, etc., increased data integration, and improved documentation of our information sources. These points are kind of pretty high level, but they do make sense when it comes to data standards and whatnot. It's kind of funny that we talk about data in kind of a very generic sense. Data can be many different things, but just keep in mind that this really applies to all types of data. It could be data that's used in a software application, data that's used by a medical staff to treat a patient, whatever it is. All right. Now, data specifications and data modeling, a little bit different, right? Because now we're talking about actually defining or designing a system for actually handling that data. And they're specifically talking about, in this case, data that might go, for example, into a database, right? Database planning includes user requirements analysis. That would include, how often do I have to access the data? What types of queries am I going to be applying to retrieve the data? Am I going to provide the ability to update the database with additional data or modify the data that exists in that database? So data modeling is a way for us to kind of identify the needs of the user, not only to acquire the data, but for data entry, right? Data modeling, by definition, is really a software engineering concept for, creating an architecture, if you will, for an information system. We essentially, generically speaking, define data modeling as a process that is used to define and analyze data requirements that are needed to support any kind of business process within the scope of an information system within the organization, if that makes sense. So there are multiple types of data models that can be created. We don't really need to get into the specifics of that, but there are conceptual data models that we can create, a logical data model, physical data models, and so on. But the idea is that we create these data modeling techniques and these methodologies so that we can ensure that we have standards, consistency, predictability to manage a particular resource, in this case, a database. This concept can be applied to many different areas, right? Integrating information systems, managing data as a resource to an organization. In this case, designing a database or a data warehouse. That is essentially what our goal is in this particular case. We need to identify the business rules, how things are done in a particular place. We have to identify the entity types, meaning who is going to be accessing that information, conceptual, logical, and physical schemas that I talked about previously. Whether we use one of those or not will depend on how we're applying these modeling techniques or modeling methodologies to our overall design. All right, let's see. Must identify the path to meet the user requirements, right? Keep a model and a data structure simple, but address the project rules, goals, and objectives. Data modeling processes are iterative and interactive and should include these questions. And again, this is specific to a database that's housing information or a data archive. What are the database objectives and how will the database meet these objectives? Who are the stakeholders and who has a vested interest in the use of this particular database? Who will use the database and what database tasks need to be accomplished? In other words, are we pulling information? Are we pulling information on a regular basis? Are we pulling a lot of information or small amounts of information at a time? What is the information that's actually going to be stored in the database? And how long will it be valid for? How long will it be held? And will the database interact with other databases? All right. So this is just an example of a data modeling technique as it's applied to, a database, if you will. There are, if you go out and look for, data modeling in general, there are hundreds and hundreds or thousands of articles on data modeling as it applies to many different aspects of computing. We're not going to get into that in detail here. Maintaining the database, technology obsolescence can be a significant cause of information loss. Maybe we invested in a database for a small business, and that database is very good at function for small amounts of data. But as the company grows, and as the information we're collecting grows, it outgrows the database or even the physical device that stores that database, right? So data might get corrupted or otherwise unusable. We have to manage the infrastructure hardware, the software, the file formats, the storage media. Major hardware changes typically happen every 1 to 2 years. Software changes every 1 to 3 years. We have to have a good day-to-day system administration, which includes threat analysis and threat mitigation. I don't know that we're doing that day-to-day, but there are certainly other tasks that we're performing day-to-day. Archiving the database, backing up the database, updating information within the database, and so on. But security should, of course, always be a concern. Threat hunting and threat analysis is important. Identify information that identify the information needs of the organization and apply levels of importance, strategic importance to those particular needs. Identify the, I don't know that this is a maintenance and audit concept. This would be something that I would probably do prior to providing access to that data, but I certainly would want to audit whether or not those needs are being met, right? And if those needs change over time, how do we adapt to those changes? Identify resources and services provided to meet needs, mapping information flows, and analyze gaps, duplications, inefficiencies, and over-provisioning. Data duplication can be a big issue, especially if you're collecting information from multiple sources. The concept of data deduplication is getting rid of those redundancies because that makes the database more complex. There is the possibility that if data is duplicated, that some data sets might be modified and other data sets won't be modified. And then when somebody's accessing that information, they think they're accessing accurate information as it's related to what they're trying to access, but it turns out there's a different version of that information stored somewhere else, right? Okay. Data storage includes how we're storing the information. Is it digitally? Is it a hard copy of the data? Remember I said, we're talking about data, but data comes in many, many forms, right? A lot of people still have actual paperwork, and they just simply store that paperwork. Without planning for storage, problems can result in out-of-date and unusable information. Physical data set storage and archiving items include the server, hardware, and software. What is the database type of the data? Is the infrastructure, do we have infrastructure in place already for the archival and storage of that information, or is it something new? Is there a specific database project that is required? What is the network infrastructure that's required to be able to access the data? How much bandwidth is required to access that information? Are we doing time of use, time of check scenarios where we're looking at when the data is going to be accessed? What is the size of the data set? What is the format of the data set? How are we maintaining the database? What are procedures for updating the database to newer versions? How are we making additions, modifications, deletions? Are those happening on a regular basis? Because that's going to mean that we're going to have operations that have to take place, and we may have to add additional compute resources to do that. What are the database backup and recovery requirements? All right, what is the process of backing up the database, and what is the process of recovering information if that information is lost? That's a really, really important concept. We want to make sure that we're maintaining the availability of that information. Okay? All right, moving